So let's start recording. And let's open the lecture slides. Screen share. Okay. Yeah, so that's perfect. Yeah. Oh yeah. So the last time I saw you guys were doing the example of the turn-based game, right? So we had a start phase, we had a game loop, and we had an end goal, right? Or an end state, right? So let's actually continue with that. Yeah, so before we continue with the advanced JavaFX slides, let's just start with this and just try to finish it as soon as possible. Yeah, so that would be not that. It would be that. Yeah, so where we were is we had the game object. So we created a class, called it a game object. It might seem counterintuitive that this class, for example, is called game object when, as a matter of fact, it is a class, right? Because in object orientation terms, we usually refer to an instance of a class as an object, right? But usually in game development, the class that kind of has a game loop and updates the game world and the game state is usually referred to as a game object. So I decided to stick with that convention. But you can name this class whatever you want. It's really up to you. So just to recap on the game, we had a player, we had a sum that the player had to calculate. We had a left-hand side, which was generated randomly. So it's a number in the range, I think, 0 to 500. And then we had a right-hand side, which is also generated randomly, right? And then so when calculating the random sum, we use the calculate random sum method. You could, for example, design this differently and make this return an integer and not have this private member attributes at all, right? So really up to you how you go about designing your own game. But obviously, this is just an example, a very simplistic example compared to what you have to do for practical eds, right? Okay, so here we have our run method. So our class implements the runnable interface, which means we will have to run it using a thread. So we need to create a thread in main and then provide this game object as a task to the thread and then start the thread in order to run the task, right? So here, so we have, we ask the user to enter the sum of the left-hand side and right-hand side, and then we read in that value. And then if the sum is the same as our sum, then we say that the user wins and the end state has been reached. But if that is not the case, which means that the user's answer is wrong, then we need to decrease the number of tries remaining. So let's just, so go to player, decrease number of tries remaining, let's just name that correctly. Where is the method? Oh yeah, okay. So number of tries. Okay, so that's that. And then if it's 0, then the game will be over, which means that we will have reached the end state. But if it's not 0, it means that we just say to the user they provided the wrong answer and they need to try again, right? So so let's actually create the game object in main. So game object X is, and let's just import. Let's just check the constructor. What does it take? So it takes the number of attempts that the player is allowed to have. So let's provide that. Let's say the player has 3 maximum attempts. And then so we need to create a thread. And provide the game object to the thread. And then after doing that, we have to start the thread, right? So start. We really want to be, very strict. Let's say, for example, we had more than one thread in our application and we wanted to wait for this thread to complete its execution before any other thread runs. Then what we can do is we can say, so after the start, we can say game thread dot join, and we have to catch the interrupted exception, right? But so in this way, we will make sure that the thread runs until it finishes, right? So, and then we can output a message. Executing, okay. So let's see what happens. Crossing fingers. Okay, so already some errors. So let's find out. There's probably some problem with our scoping. So let's check the constructor. Okay, this ends there. Run. So what is this? Let's just remove that. Yeah. So, oh yeah. So we need to close this. So we need to close it. So let's just rather do this. And close it here. Thank you very much. Yeah. All right. So now, if we run this, so it looks like it works. So let's try it out. So 428 and 473, who's good at adding numbers in their heads here? What is the answer to that? Anyone? Yeah, so, sorry? Sorry? 800 and? 801. I do not think so. 901. Okay. Yeah, so it says exception in thread. For input string 901. Oh yeah, that's because there's a space character before the number, so it couldn't convert it to an integer, right? So we need to eliminate that. So let's try again. So 901. Oh yeah, so wrong answer, try again. At least we know our game works, right? But yeah, so what's the sum of 190 and 498? Sorry? 608. Okay. Sorry? Oh, 688. Okay. All right, so 688. And there we go, right? So you win, game done executing. Does this make sense? Okay, so the most important thing here, yes. The decrease. That is a good question. So you can make this method static here, but if you made it static, right, that would mean you are making the assumption that your game can only have one player playing at a time, right? So remember, so let's say, for example, you are designing this game and it's like, like it's in production and everything. You might want to create a player object, right? Because remember, an object has its own state, right? So if the number of tries remaining for this player object is 5, and then you decrease it to 4, right? When you create another player object, that will still be 5, right? So then only this object will be affected, which means that if you decide to save this game, so let's say it's a GUI game and you click on save, and then you save the player as a binary file, right? So you save it into a binary file using a object output stream, right? Then when you load it again tomorrow, right, from the binary file, then you load that particular object, right, the player object with the number of tries remaining, that is 4, right? But if you make it static, then you're making it apply to every player instance. So in that case, it would affect every player object that you create, because a static variable is a class level variable. It's not an object level variable. Yeah. So you might just want to think about that. Yeah. Okay. But let's actually test it. So let's see if it works. So let's just enter 5, 5, 5. Okay, so that's perfect. That works. Let's try something else. So let's say, for example, the player can increase their score, right? So let's say every time they answer something correctly, they don't just win, but they accumulate their score, right? So let's do that. So if they get the right sum, so we store output. So let's say correct answer, and then we need to output the score. So let's, okay, because of time, let's just use print line, and then current score is player dot get score, right? So that's the score. And let's output the number of tries remaining as well. So let's actually make these independent of these possible conditions, and let's actually put them here. So let's say we output the current score here, and we output the number of, well, let's say, so it's number of attempts remaining. Where is it? So get score, get tries remaining. So get tries remaining, tries remaining. Yeah, so now we output the score, number of tries remaining, and we ask the user for that. Let's do this as well. So just divide the two things. And then, so let's see what happens. So here, now when they give the correct answer, so then we say player dot increase score. And then so that will increase the score by 1, but the end state will not have been reached, right? So let's say the player, to terminate the game, they need to type quit or something, right? So then we need to check. So we need to enter the sum. So before doing that, we need to first take it as a string. And then just say if so if this is not the same as quit, then okay, let's just do this quickly. Okay, so if it's not the same as quit, then you can do all of this. So let's just, yeah, so input, right? But if it is, then end state reached is true. Yeah, so if the player presses quit, we just quit the game, right? So yeah, so let's try that. Yeah, so current score is 0, 3 tries remaining. What's 189 plus 356? Okay, let's just type it out. 189 plus 356, 545, 545. Correct answer, current score 1, number of tries remaining. You guys get the points, right? And then, so if we type quit, and then that's done, right? So the most important thing for us to take here is a game has 3 stages, right? It has a start condition where you do all the initialization, right? In our case, we do the initialization by creating a game object, right? So create a game object. What does a game object do? It takes care of all the initialization, right? So we create a player, and then we start the game, right? Calculate a random sum. Okay, well, this doesn't really start the game. Calculate the sum. And then after initializing the player and the sum, then we start the game loop, right? How do you start the game loop? Well, we take our runnable task and put it inside of a thread and start the thread, right? So we start the thread, and then that becomes the game loop. As you can see, the run method simply has a do while loop, which runs until eternity, up until the player decides to quit, right? Unless they lose, right? So that's the game loop, right? And then there's a third stage, which is the end state, right? The end state is only reachable in certain cases, right? The first case is when the player decides to quit. The second case is when the player loses, right? That's the only time they can reach the end state, right? It's like Miss Pac-Man. If you're playing Miss Pac-Man, I don't think any of you here have ever finished all the levels. Is that even possible? Exactly, right? So the end state for Miss Pac-Man does not include you winning, right? It includes you losing or quitting the game. Or, well, to quit Miss Pac-Man, you would have to unplug the machine. So that's not really an end state, but it includes you losing, right? So, but do you guys get the point, right? So that's very important for games. So hopefully this helps with your practical X, and now you're able to divide your game into 3 different logical compartments. Yes. Sorry? I can't hear you. Yes. Yeah. Okay, so remember the game loop just means the part where your game is actually where you actually playing, right? So that's the game loop. So it doesn't have to be like a thing where like you make a wrong attempt and then it restarts, like it resets the state, right? It can be a continuous thing, but the most important thing is that the game loop continues until you reach an end state, right? So that's the most important thing. Yes. Yeah. Yeah. Yes. So initialization is not necessarily creating a brand new player, right? Initialization just means creating the conditions that are enough for the game loop to start, right? So if you're loading a player from the file, you are still initializing the game because you are just trying to get everything ready so that your game loop can start. Yeah. Yes, that's very important. Yeah. So the difference between the game loop and the game mechanics is that the game mechanics are all the possible things that you can do during the game loop, right? So for example, the game mechanics for this game is typing quit or entering the correct answer or entering the incorrect answer, right? Those are the game mechanics, right? So it's the physics rules of the game, everything that you can do as a player in the game. Those are the game mechanics. The loop is the actual game while it's in execution, right? So the loop involves you applying the game mechanics and the game reacting to what you are doing. All of that forms the game loop. So you can think of it like that. I mean, how you choose to like interpret it is up to you. But the most important thing is that the game mechanics are the actions that you can do in order to reach an end state, right? So they can make the game loop continue, or they can cause the game loop to stop for you to reach an end state. But the game loop is just that phase where the game is just executing. Yeah. So you can say, for example, from your perspective as the human, as you play the game, that's the game loop, right? As the game reacts to you, right? And then you can say the game mechanics is how you affect the game state. So how the state of the game is changing. Yeah. Yeah. So there's no like concrete definition of it. It's very abstract, right? Because I mean, games are different. So it depends on the game that you're playing, what the game loop would be in that context. Is that okay? Yeah. So yeah. So if you want to chat more about it, yeah, we can talk about it after class. Okay, so but that's basically the idea, right? Any other questions regarding this? Okay, so let us go to the lecture slides. Yeah, so let's just do this. I think this will be quicker. Yeah. Okay, so this set of slides is basically about like advanced Java FX features. So it's not really like something we will ask you to do, for example, in an exam or the semester test 3. So do not worry about being able to create some of these components or things like that, right? This is purely for enrichment, right? So tomorrow morning, I'll do a tutorial with you guys where I demonstrate one of these. I'll decide what to do with you guys, but it's purely to stir your interest and maybe help you make your games more interesting, right? So the first thing that we'll look at is look, feel, and consistency. So Java has two primary frameworks for graphical user interfaces. It's actually three, but the third one is so old that virtually no one uses it anymore, right? It's called the abstract windowing toolkit, right? So if, for example, you are inputting a library, you may have seen something called java.awt.something something, right? So AWT is the old GUI framework, and then they moved from that, and then they moved into something called Swing, right? So java.swing.button and so forth, right? And then came JavaFX, right? So JavaFX, I'm not really great on the history of how they merged with Java and separated again, but the whole idea is that you can use JavaFX to create much more rich applications, for mobile, for web, and even for desktop applications, right? So it's much, much more advanced than Swing, and it allows you to do much, much more, right? So as we will see in these slides. So Swing is outdated in terms of its look and feel. I can show you guys a quick example. So here's an example of a Java Swing. Yeah, so let's use this input dialog and enter a value. Yeah, so let's just leave all of this out. Just to show you guys how it looks. So as you can see, that looks very old, right? So you would have to do a lot of work to actually try and make that look pretty, right? So that's just an example of what this text means, right? So it is outdated. So JavaFX allows for you to skin your UI, right? So if you have if you're interested, for example, in changing how your applications look, you would know about like skinning like a UI and all of the stuff, making it look nicer. And with JavaFX, you can do that with cascading style sheets, right? You learn more about cascading style sheets in informatics 2B, right? When you start doing web development, right? But basically, it's called CSS, and it's used to make websites look nicer, right? So JavaFX uses the same technology to make applications look nicer, right? So we didn't really use any of these during like this semester. We don't really use CSS for JavaFX in computer science too, but like it is a really interesting feature that you can, for example, play around with, right? So I encourage you to have a look at that and see how you can do that. And you can change the entire look and feel with just a single method call, right? So for example, there are certain methods, I think like for buttons and some of the controls where you can set the CSS by calling a method, right? And then it will apply a CSS effect immediately. Okay, so that's how you can make your JavaFX applications look nicer. There's also the consistency. So consistency has to do with the control hierarchy of a GUI framework, right? So for example, with JavaFX, the hierarchy is more complete, so to speak, because in addition to Swing, like having buttons, checkboxes, combo boxes, and so forth, JavaFX has other controls like tile panes, accordions. We did not use accordions this year. I think I need you guys create a list view where you had to read stuff from a file and then display them in a list view and then have a scroll pane and things like that. So, you know, like you have all of those types of things with JavaFX, and you can scan all of these components with CSS, right? So you can make it look nicer. and all of that stuff. Yeah, and then also have special effects in JavaFX. So you can, for example, add effects like having like reflection. So when you have text, and then make it like have like some sort of like a reflection, like some sort of like as like some sort of like effect. You can also have like shadows for your text. You can have like blurs, even for your controls and all of that stuff. I mean, it really depends on what you're trying to design. So you're not going to use all of these effects like for everything, right? It depends on what you're trying to create, which is a very, very important feature of graphical, or rather user experience, right, in general. So if you want to be a UX or UI designer as part of your career, one of the most important things to understand is there's a time and place for everything, right? So in terms of animation, Swing does not directly support animation. So you would have to, for example, create your own timers. Yes. Yeah. How's it different from a keyframe? So, okay, so the way that I understand sprites, I might be wrong. I'm not a GUI expert, but a sprite is basically like a graphic that you add onto your GUI, right? So for example, let's say you're designing a game with characters, then you would get character sprites for different like actions that the character is performing, right? So for example, you'd get a sprite for a fighting character, right? And then you'd get sprites for all of that. And then if you want them to jump, then it would show the character jumping, and then show the character walking and stuff like that. Is that what you are referring to? Yeah. It would be very difficult. So I would advise that if you are doing things like really, really complex graphics, like creating a character, right? Rather use a sprite if you can get it with like a what's this? Like a free license, right? So remember, for your practical X, do not use images that you did not get for free, right? You need to be sure that you get them under a free license, or you must credit the person who created them, right? But for your characters, I would say rather use sprites. It's much easier. Like it eliminates all of the hassle of having to figure out, like coordinates and like yeah. So like coordinates on the screen and moving your characters, how fast you are moving them, and all of that stuff. Yeah. Okay. Okay, so yeah, so JavaFX has built-in support for animation that can be applied to any node in the scene graph. Also, with animation in JavaFX, usually keyframes and all of that stuff, they are for more like uniform type of animation, and it would be really hard to try and adapt them, to create like really complex looking like characters and stuff like that. So, but you can create keyframes and use timeline classes to set up custom animations. And JavaFX also has touch support. Unfortunately, I can't demonstrate that to you guys because my laptop is not touch screen. But Swing, for example, does not have support for modern touch devices, which means that you wouldn't be able to do that straight out of the bat. I don't know if there are any third-party libraries for doing that for Swing, but natively, Swing doesn't do that. JavaFX has built-in support for common touch gestures such as scrolling, swiping, rotating, zooming, and you can handle them just like any other event, right? So it's the same as like a mouse click like events or mouse events or stuff like that. A touch events can also be handled similarly, right? So it's not something that's foreign or that's overly difficult to do. Yeah, so one thing that does not really, yeah, so also it depends on who you ask, but one thing that a lot of Java developers did not initially like about JavaFX was that it did not have a J option pane, right? So J option pane in Java is exactly what I used here, right? So there's a class in Java Swing called J option pane, and it has all of these nice things that you can do, right? So for example, this is for showing an input dialog. So if I do this, J option pane dot, so it has all of these methods, like showing a confirmed dialog, showing internal dialogues, message dialogues, and all of that stuff. It really made, like getting input from the user and, getting confirmations and all of that stuff, like it kind of streamlined it and it was really easy to use. JavaFX initially did not have that. They still don't have a class like that behaves the same as a J option pane, which is really weird because they have almost everything that Java Swing has. But the way that JavaFX does this is they have something called a dialog class, right? So the dialog class deals with all the dialogues, right? So all kinds of dialogues like alerts and all of that stuff. They are a bit of a pain to create some of them because you have to write a lot of code, but some of them are really, really easy. And luckily, the ones that are really easy are the ones that we use, on an everyday basis. So you don't really have to go out of your way to try and do that. But yeah, so that's that. So yeah, so that's actually the end of the slides. And I will find an example that I'll do with you guys tomorrow morning. And enjoy the rest of your evening. And good luck with your practical X.